Okay, what are we doing? We are talking about abacus. Okay, so we got that, we got that, we got this, we got this, we got this, and we got that. Okay, so what are we doing? We're talking about the abacus. This is what an abacus is. Thank you so much for joining. Thank you so much for joining. We're talking about the abacus. This is a counting tool. This counting tool, just so you know, we're talking about math. Welcome to my math room. So what we're going to do is we're going to count on the abacus. This is an abacus. This is a counting tool. This counting tool helps me count. So when we look at it, we have 1, 2, 3, 4. Notice all the beads that are touching the horizontal bar. In contact with the horizontal bar, it is now being counted. Hello, Ethan. Welcome. Good morning, Ethan. Good morning, Ethan. How are you today? I hope you're going to be well today. Yeah? So what are we doing? We're reading the abacus. So when we read the abacus, this is a value of 4, right? How do we know this is 4? This is 4 because all of these beads have a value of 1. When we look, we're going to do 1, 2, 3, 4, and then we have the top bead. The top bead will be a value of 5. So when we look at it, this is 5. We have we have 0. This is 0. That's 0. Then we have 1. This is 1, right? And then we have 2. We have 2 beads, 2 beads, right? Not 1, 2, not 2, 1, not 1, 2, 2, 1, right? 1, 2, 1, 2, 1. This is 2. Here is 3. This is 3 beads. 1, 2, 3. I have 3 beads here. Doesn't matter. Doesn't matter if it's these 3 or these 3. There's are 3 beads, right? These are 3 beads. And then that's 4 beads. 4 beads. After 4, we have 5. 5 will always be the top value. 5 will always be up here. 5 and then 6. Notice we have 1 and 6. 1 and 5. 1 and 5 is 6. And then we have 7. 1, 5, 6, 7. And then 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. Anybody have any questions, let me know. What we're doing is we're learning how to read the abacus. So here is another way to read the abacus, just so you know, right? When I have it in my place values, this is what I do. So when I look, right, I have my ones, my tens, my hundreds, my thousands, my 10,000. When we look at it, this is my ones. How do I know this is my ones? Because I have my indicator here. Here's my label. This label tells me that this is the ones. I can do ones, tens, hundred thousands, 10,000. So let's review again. Review. This is 1. Boss lady, why do you know what made you what? Sorry. All of these people are coming in. Hold on, hold on. Why do you know this? What made you learn this? I learned this because my dad told me to learn it so we can build a business. So we're trying to build a business on the side, and that's what it was. It was because he wanted to start a he wanted to because my dad wanted to start a learning center to teach kids how to use the abacus. That's why. I didn't learn the abacus when I was young. I actually learned it when I was old. But my kids know it, and my kids like it. Well, they like it now, but when they were doing it, they didn't like it. Because who likes to do more work? But really, it actually helped them a lot because when they went through Common Core, they didn't have a problem with it, and I didn't have to help them because they know how to do it through the abacus. I hope that made sense. Bradley, Brad, yeah, good. Okay, let's see. Um, uh, and block. That's not sorry. I've never seen one in person. Oh, yeah. So I'm teaching the kids, I'm teaching the adults how to use an abacus. So what we're doing, sorry, I just was taking some time to bump some people off, like this person, Brendo. Okay, so yeah, yeah. Oh, hey, similar dreams. No, we didn't have similar dreams. I really do believe in the abacus. He just was trying to find a retirement. So hi Eve, welcome back Eve. How are you doing? How are you doing? So what we're doing is we're going to be reading the abacus, and that's what we always do. We always start with reading the abacus first. So we're going to count 1, 2, 3, 4. Now sometimes if we did it this way, right? We have 1, 2, 3, 4. For those of you that know this, these are pennies. This is worth 1 cent. 1 cent. So in American money, this is worth 1 cent. So when we look, this is one, excuse me, two, three, four. Do you ever listen to Al Green? Yes, I know who Al Green is. So we have four. 1, 2, 3, 4. And then we have five. The top beat is a value of 5. That's what this is. This is the value of 5. This is a nickel in America. This is a nickel. This is worth 5 cents. So when we do it, this is 5. When we add this would be 6. And then we have 7. And then we have 8. And then we have 9. Does that make sense? So when we read the abacus, you're always just going to get 9 no matter what. This is 9, 9, 9, 9, 9. These are all 9s, and then 9, 9. So when we look, this is about, these are all values of 9. So we have 99.99. That's what that means. Wait, start over. Hold on. Very awesome of you. Thank you so much. Thank you so much, Brady. I hope to see you again in my next live. So what we're doing is we're learning to read the abacus. To learn to read the abacus, we're understanding how the abacus is read. So what I just showed you was how the columns are. Every column is a digit. So when we count, right, and I'm going to use the money to help us, we're going to do 1. So we have 1, right? 1 bead is a value. This is a value of 1. This is 2. This is a value of 2, right? We have 3. That's what 3 looks like. We have 4. That's what 4 is, right? Does that make sense? Where are you? User 871. So when we look, right, when we have the value of 5, this is the value of 5. I'm going to move it away, and that's what value of 5 is. This is what 5 is. 5 is always going to be the top bead no matter what. The top bead will always be a value of 5. So when we have 6, that's what 6 is. We're going to add it to the thing, right? And then we have 7, and we have add 7 like that. We have 8, that's what 8 looks like, and then we add that. And then 9, we add 9. That's what 9 looks like. Anybody have any questions? What we're doing is we're reading the abacus. When we look, we have our ones, our tens, our hundreds, our thousands, our 10,000. We have our tenths, and then we have our hundreds. Notice that in between the ones and the tenths is my decimal. That decimal is, then we have the rest of this, the decimal. Now, if you notice, I actually have 2 indicators. There's one here, and there's one here. I like to choose this one like a Pokemon. I like to choose this one because then I have all these numbers to be big. However, if I chose this one to be my ones place, then I have to move everything over and it'd look like that. This would be the ones, the tens, and then notice I don't have any more beats, any more columns for the hundreds. So we're stuck at 2-digit, but then we have all of these as my decimals. Does that make sense? So, excuse me. Let me know if you have any questions. So we have 5, and then we have 6. 6, and then we have 7. This is 8, and then this is 9. 9 looks like that. Well, you might be asking, well, what happens to 10? 10 is exactly the way we write it. 10 is a 0 and a 1. And that's what it looks like. 0, 1, 1, 0, 0, 1. That's what 10 looks like. When we do it, that would be 11, right? 1 and 1. What you going to do? So 1, this is 11. And then we have 12. 12 is 1 and a 2. Just like that. 1 and 2. When we do 13, 14, and then 15. 15 will always be, the top bead will always be 5. When we look, this is 15. We have 100, 15, 200. Now we can count by hundreds. 200, 300, 300, 300, 400, 400, 500, 500, 00, 600, 600, 700, 000, right? Does that make sense? So what we're doing is we're just counting on every column. When we count, it's exactly the same except that it is in a different place value. Start over? Yeah, sure. When we count, every bead that's in contact with the horizontal bar is being counted. So when I have 1, that is 1. I have math dyslexia. Do you have any tips for getting the hang of math? If you have math dyslexia, I actually don't know what that is. You could try the abacus because it's tangible. So you know what, Molly? Let's see how you fare with what I show you on the abacus. We can try it. I don't know. I don't know what math dyslexia means. So here is one. Molly, does that make sense to have one? Now because you guys are yes, thank you. Oh, hey, Apple user, welcome back. Yeah. So this is one. That's one, right? If I have two, it'd be two, right? Because I have two. This is the value of two. These are the value of two. It's just these are the two beats, right? So what we're looking at is we're looking at how to read the abacus. This is three. So if I show you another penny, this is three, right? Three pennies with three beads. So I'm trying to do is I'm trying to relate them together. It might make more sense when I have four. One, two, three, four. Okay. So what after four, then we have five. The top beat will always be five, no matter what. So that's what this would be. This would be the nickel, right? So that is worth a five. The top beat is always have a value of five, no matter what. Does that make sense, Molly? I don't know if Molly's still here. Molly, are you here? Yes, thank you, Apple user. The top beat is always five. Hey, yeah. It basically means my brain has disconnected from math, so it makes no sense to me. But you're helping. Molly. Oh, okay, good. Yeah, no, let me know if it makes sense. Okay, good. Let me know if it doesn't make sense, and then we'll take it slow. We'll take it a different way. But for the first part, we need to understand this is the value of five. Okay, so I don't know if you deal with money, but this is a nickel. A nickel is worth 5 cents. I don't know where you are, but in America, this is a nickel, and a nickel is worth 5 cents. When I add one, right? When I add one, that's one. This is six. That's six, right? Five, six. Make sense? So then we look, right? We're in every place value ones, tens, hundred, thousands, 10,000. Every column is a place value. So we have six, six, five, six, and then seven. So what about, yeah, there you go, General. Yes, seven looks like that. Five, six, seven, right? What we're doing is we're trying to learn, we're just trying to understand how to read the abacus. When we understand how to read the abacus, then we can actually do adding, subtracting, multiplication, division. Yes, thank you, Apple user. When we do one, well, the first thing is we need to know this is one. Then this is two. We have two beads. These are the two beads, right? This is not one, two. It could be one, two. It doesn't matter. These are the two beads, right? This is three. That's what three looks like. Three beads. This is four, and we have four beads, right? The four is the pennies, right? Four pennies. One, two, three, four. 1 cent each. So this is four. When I do five, I need to remove that and I need to put down the five. So the five is always going to be at the top beat no matter what. So if I have five here, five, 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 five. All the top beat is five. I've never seen anyone actually use the abacus. Thank you for showing us. Yeah, not a problem, General. So, but we can continue more. Ah, 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 ah. Thank you, Apple user. So we have this. This is six. Notice this is six. One, five, and one bead, right? So this is five, this is six. And then we have seven. We're just doing a review. Five, six, seven, and then eight, right? Five, six, seven, eight. We're just doing a review. We're not doing anything. We're just reviewing, right? We want to know as we understand, right? Molly, do you understand all of this? Is that making sense? This is nine. This is nine. Does that make sense, Molly? Now I'm just focused. Hey, Ethan. Good morning, Ethan. Okay, what are we doing? We're going to do 10. What's 10? Well, if you notice, this is 1. If this is 1, that will be 10. What? Yes, it's simple. Because just as we write, we have our ones and our tens. Look at that. There's 1 and a 0. 1, 0. That's 10. The random number generator. Right? So after 10 is 11. After 11 is 12. I don't know if Molly's still here, but does this make sense, Molly? So what we're doing is we're looking at the numbers, and this is 1 and 2. So when we look, this is 1 and 2. 1, 2. This is 12. Now we can go, if this is 12, right, we could do 22, 32, 42. Oh, good, Sarah. Good. 42. right? This is 40, this is 2, this is 4, 1, 2, 3, 4, and then this is 2, 1, 2. And then we do this. This is 52, 62, 72, 82, 92, right? How do you choose where to start counting as far as ones? Ooh, good question, King. When you notice I have this label, this dot here is a label. This label is my ones place. Notice I have two, and I choose this one, like a Pokemon. You could choose this one if you want, but I chose this one. If you choose this one to be your ones place, when you choose that to be your ones place, it's fine. But then you notice that you only have ones and tens. You can't go higher than hundreds because you don't have any more columns. Does that make sense, King? So when you look, that's why I choose this one to be my abacus. I'm sorry, my ones place. Because I have ones, tens, hundred, thousands, 10,000. Yes, good. So then if you notice the ones and the tenths, the decimal sits between the ones and the tenths. So because it's the ones and the tenths, now we have our decimals and then we have our hundreds. If we look, if I wanted to really utilize the money like we have, right? This would be $1 and 1 cent. That would be $1, 1 cent, right? 2 cents, right? That'd be 2 cents. 3 cents, 4 cents, and then 5 cents. That'd be 5 cents, right? 6 cents, 7 cents, 8 cents, 9 cents, right? That's 9 cents. If I needed 10 cents, I have a 10 cent here. This is 10 cents. So it would be look like that. So it'd be 19. I want my kids to learn math like this. Oh, great. I have books, I have worksheets, and I have abacus. Oh, I have abacus. How old are your kids, may I ask? Because it depends on how you talk to them. You know what I mean? Like if they're young, then there would be certain things I wouldn't explain to them. You know what I mean? So, but the first thing we're going to do is we're going to understand how to read when we read the abacus. So we understand this? Yes, Molly? They're not old enough yet. Are they 2? if they're 3, if they're 3, I do have this where we talk about two. Oh yeah, almost. That is definitely not old enough. But you know what? I made this one specifically for preschools, just so you know. And what it is it's a lot about bead recognition and looking at the number. So here is a little bit of an example of what we were just doing is understanding what the beads are with the numbers, right? And so we were looking at the numbers and we practiced how to do the understanding what the 3 looks like. And then after that, we have activities, counting the circling and counting on to this and then recognizing what it would be. So this is 4 oranges. They write the number 4 and then they would have to find the number 4 in on the abacus. So here is another thing. They don't need to go any specific way. I just wanted them to just choose a path. And because they get to choose a path, they just need to follow in where the numbers are. So this is just an overview of what this book is about. And I was trying to hit the kids young. Afterwards, after they understand how to read, they go into counting forwards and counting backwards, and then they have the bigger than and the less than. And then what happens after that is what we're going to go right now is to understand how to add. What we're going to do is we're going to learn how to move the beads. Why? Because we need to understand that we want to be happy when we do the beads, right? How long does it take? I'm sorry. How long does it take until they can do in a couple of seconds? Well, that is it probably take a couple of years. One, because they need to know how to add and subtract. Two, they need to know their multiplication facts. And three, they would have to really practice. It's like playing the piano, then it becomes intuitive. My kids, I have 3 boys. They don't do it in their heads because I never forced them to, but they can do it on the abacus pretty quickly. It's like riding a bike. Once they know how to do it, then it's pretty easy. Okay. Yes, thank you, Ethan. It depends. If it's very fast, they learn abacus after years. Yeah. I mean, it does take an investment, right? It takes an investment to understand how to read, but it's just like, learning math. What we're doing is we're learning math with an abacus. And notice when I work with the beads, right? Even this is a standard size. The way the beads are and the way the height of the abacus, it's a standard size. We're all going to be very gentle when we work the beads, and we're going to be happy. You don't need to be aggressive. You don't need to be aggressive when you work the beads, because notice we're only working at the edges of the beads, right? This is the edge. We only need to like focus on the edge and just be gentle with it, right? So when we do it, when we work with it, we don't want to be aggressive. The reason why is because they're very easy to move. And you do not want to flick too hard or your numbers will be wrong, right? Your answer will be wrong. Don't flick too hard, right? So you want to be careful when you move your beads. Don't flick too hard because they're very easy to move. And so that's the other thing is you want to use your left hand to stabilize the abacus, because if you bump it, then you're going to get a wrong answer. It's just the way it is. And it's very easy, but then that's where you get attention to detail and you also be stable. So when you also look, you want to make sure that you're on a flat surface, or else again, all your beads will be not will be mistaken. So these are just some of the tips when we work with the abacus to just be mindful of the tool. So here again, what we're doing is we're learning how to do the abacus. We're learning how to add with the add-in. We're not focusing on the result. We want to know what the procedure is. We want to know the journey. The journey is the add-in, right? So here's my question. I have 5. When I have 5 and then I add the 1. When I add 1, then I know my answer is 6. Now we're going into understanding how we read the abacus. Does that make sense? So we're slowly understanding how to move the beads, and then we're going to go into understanding, and then we'll go into reading it, right? So what we're doing is we're building our information. We're building and compounding our information. Hello, abacus geniuses and Suburban Joe and Amanda. Hello, Jesse. Welcome. Okay. So when we do it, this is 7. We have 7. We want to add the 1. When we add the 1, we're just moving the one bead. It doesn't matter which bead. It doesn't matter what bead it is. It could be this one. It could be this one. It could be this one. It doesn't matter as long as it's one bead, right? That's why we don't want to label it to say that this is 1, 2, 3, 4. It's not that way, because it can be any number of these. These are the value of 1. So when we're adding this one, like, right? We have 8, and then we add, oh, you can't see it. Well, this is 8, and we want to add the 1. We want to add the 1. So my final answer is 9. Again, we're not focusing on the result. What we're doing is focusing on the add-in. So this specific question is adding 1. And then when we want to do is we want to add 2. When we add 2, again, what we're doing is we have the 5. When we add the 5, we want to add the 2. When we add 2, it's these 2 beads. Notice I go up to the horizontal bar. And then when I subtract, it's minus. I want to take it away from the horizontal bar. So now we know how to add, we will know how to subtract. It is not two different strategies, because I know in mainstream math they give you one way to add and another way to subtract. In abacus, if you know how to add it, you'll know how to subtract, because it's just the opposite, right? So if we go to the horizontal bar, we're adding. If we're going subtracting away from the horizontal bar, right, now we're subtracting. Does that make sense? Let me know if everybody's okay. If you have any questions, whoa. Let me know if you have any questions. We're going to continue on with how to add the 3. Adding the 3 is just as easy as adding the 2. If you notice, 1, 2, 3, that's what we're going to do. We're going to add the 3. Oh, good, Sarah. Let me know if I talk too fast, because I know I talk really fast when it comes to stuff like this, because I've been repeating myself quite often. So when we look, right, we have 3. When we add the 3, again, we're going to the horizontal bar. I want to add the 1. Now I have 4. If I want to take away 3, 1, 2, 3, I'm going to be a big person, take away 3 at the same time. I also laugh at my own jokes, just so you know. So we have 3 and then 4 and then take away 3, right? These are the 3 beads. If I have 3 here, these are the 3 beads, right? So understand we're looking at the beads and we're moving the beads, right? When I look at it, I'm only moving the edge of the bead, okay? I'm not being aggressive. I'm just being gentle. So that's 2, and then we're at 3. So if you notice, what is this thing on the side? This thing is a puzzle. You answer the question here, and then you find the answer on the puzzle piece. That's what that is. All right, 3, same thing. We have 5, and then we're gonna add the 3. When we add the 3, we're just gonna do that. That's it. My answer is 8, and we're done. Are we done? No, we're not done, because now we have 4. When we have 4, we add the 5, and then my question is do I have enough? Is there enough? Can we do it? Yes, we can. So we're going to add the 4, and that's it. So my final answer is 9. Does that make sense? So, and it's again, we do it again for the minus, right? We know how to minus when we have 4, and I want to take away the 2. Can we do it? Yes, we can. We're going to take away the 2. So my final answer is 2. And then we keep going to the 3 and the 4 and the 5, right? The 5 is the same way. Is the 6 the same way too? When we add the 6, we bring it together. We want to, and then let's say we have 8 and we want to take away the 6. It's take it away the 6. So my final answer is 2. So this is very visual and very tactile, right? And so what we're trying to do is we're trying to show how easy it is to read the abacus as we move the beads. So we add the 6, we take away the 6. Add the 6, take away the 6. Make sense? Anybody have any questions? Questions? So again, we did the 8. We did the 8. We did the 8 already. So if we have 9, right, and we take away the 8, this is what 8 looks like. That's all it is. Okay. How are we doing? Anybody have any questions? Should I repeat? Should I review a little bit? Are we okay? It seems like Sarah's the only one here. King, I don't know if King's still here. Okay. So what we're going to do is, here's a question. What happens when there's not, are the steps complex but, I'm sorry. Are the steps complex but solving it easy? Yes, King is still here. The steps are not complex. The steps are not complex. The steps are easy. It's just changing the way we think. I think that's the difficult part, Ethan. You know what I mean? Because we're so used to looking at the result. Okay, so here's the question is what happens when we don't have enough, right? We've done it where there's enough, right? We have 3 and we want to add the 6. Yes. Is there enough? Yes, there is. There is enough. Now what we're going to do is we're going to take one step further. What does that mean? Well, there's this concept that we're teaching the kids nowadays. Why are we teaching? You know what? I don't know if anybody knows why we're teaching the kids how to add how to make a 5. I don't know why we're teaching the kids how to make a 5. I know why I teach my kids how to make a 5. How do these work? Hi, Katie. So I don't know if anybody knows why we're teaching the kids how to make a 5. That would be great to know. Then I can like understand. But I don't know why we're teaching the kids how to make a 5. So let's do a little review. Let's do a little review. When I count, this is 1, 2, 3, 4. The top bead is always a value of 5 no matter what. The blue bead is always a value of 5 no matter what. So we have 5 and then we have 6. 5, 6. This is my abacus. This is my aloha purple gray. This is my horizontal bar. This horizontal bar tracks my beads. Anytime the beads are touching or in contact with the horizontal bar, this is what's being counted. So we have 6, 5, 6, and then we have 7, 5, 6, 7, right? This is 7. These are zeros. And then we have 8. Hello! Welcome back, Amy. This is 8, 5, 6, 7, 8, and then this is 9. 5, 6, 7, 8, 9. Okay? So, Katie, I don't know if you're still here. Oh, thank you. Thank you, Katie, for the follow. So, when we do, oh my God, I used this in the first grade in Egypt. Hey, that's pretty cool. So, this is 10. I hope Katie's still around. Katie, this is 10. How do I know this is 10? So, if you look, this is 0 and sorry, this is 0 and 1. When we look, we have this. Every column is a place value. Ones, tens, hundred, thousands, 10,000. Hey, Jesse, how far did you go to multiplication and division? Did you use this in second grade as well, or did they stop at first grade? That's really interesting. So notice that I have 11, right? 1 and 1. That's what 11 looks like. And then this is 12. 1 and 2. Okay? Okay. So then what we did is we learned how to add. We were adding 5 plus 4. We're moving to the horizontal bar. When it goes to the horizontal bar, we're adding. When we're subtracting, we go away from the horizontal bar. We never did multiplication. It was an extracurricular. What? I stayed for first grade only. Ah, sad face. You could do adding, subtracting, multiplication, and division on the abacus. We can go into it, but it depends on how far we get. Okay, so what happens when we don't have enough beads? One thing is we're teaching the kids how to add the 5. Does anybody know why we're teaching the kids how to add the 5? I don't know. I was just wondering, why are we teaching the kids how to make a 5? Why are we using a 5 frame? I don't know why. I know why we do it in abacus. But why are we doing it why are we doing it in mainstream math? I don't know. I'm just trying to figure that out. So here's the question for us, right? The question we have is 3 plus 4. You'll notice when I have a 3 and I want to add the 4, there's not enough beads. This is why we're using this formula, right? How else would you do it? How else would you add a 4? You can count on your fingers. 3 plus 4, right, is 7. You can count on your fingers. You can use a number line, right? You could do that too, right? How else can you add a 4? Well, let me show you in the abacus way. We have this addition. Hey, RT, welcome back. So here we have 4 plus 1. We have 4 plus 1 is equal to 5. So what are we trying to do? We're trying to utilize this 5. Okay? We're trying to utilize this 5. Why? Because that's what we have. So we have 3 plus 4. We want to add the 4. To do that, we're going to, what are we going to do? We're going to do, so we're going to modify this. What are we going to do? We're going to isolate the 4 and we're going to equals to 5. When we equal to 5, that's too much. So we need to minus the 5, minus the 1. What are we learning today? We're learning how to add and subtract math. We're doing math. We're doing arithmetic. So what does that mean? We're going to add the 5 and we're going to take away the 1. So my final answer is 7. Does that make sense? So what did I try to do? I'm trying to understand why do we use the 5 to make our answer. We can do it again. We can be more versatile. Again, in the abacus world, we don't memorize our doubles. What we do, okay, good, Katie, you're still here. What we do is we do not memorize doubles, right? Why? Because it doesn't make any sense. What we do here is we can show you and compound and practice. We want to add the 4. Notice I want to add a 4 here. I cannot add a 4. What do? All I have to do is add the 5. That's too much, right? Adding the 5 is too much. I need to take away the 1. So my final answer is 8. So what we're doing is, how else do you know how to add a 4? In school, what do? They give you a 10 frame, right? And they say 1, 2, 3, 4. And then they say, okay, add another 4. 1, 2, 3, 4. So then you're left with 2. You could do that. You could do a 10 frame. I don't know how else to add a 4. But these are all the new ways to add the 4. Whereas in the abacus, we know how to do it. This is what we're going to do. We could do it again. I'll show you how versatile understanding how this works. So if I have a 2 and I don't have enough beats to add the 2, what do? I have to plus the 5 minus 1. I have given directions. These are my directions to use the abacus. I plus the 5 minus the 1. My final answer is 6. So RT, does that make sense? So when we read it, right, we could understand this is 1, 2, 3, 4, and then this is the value of 5. 5, 6, 7, 8, 9, and then 10. So I don't know if Jussie is still here. So I was wondering, did you go to how to add a 10 as well, or did you just stay with adding the 5? So what we're doing is we're understanding. So then this can go further. Now we have more of this. Okay, good. We have more of this. We could do it again with the 3. What? What do you mean we could do it again with the 3? You can do the same concept with the 3. The question would be, what would be the question? The question is 4. We're going to add the 4. When we add the 4 and we want to add 3, is there enough? No, there's not enough beats to add the 3. Right? How else can we add the 3? How do they teach you in school? Do they just say 4 plus 3 is equal to 7? Or do they show you, 3 beads, 4 boxes, whatever? But in abacus world, what we're going to do is we take this concept, we understand that this is how to make a 5. To make a 5, we isolate the 3 and we're going to plus the 5 minus the 3. So what are we going to do? We're going to plus the 5 minus the 2. So my final answer is 7. What we're doing is I'm showing you the very basics and the fundamentals of adding the 5. Because why? The reason why is because then we can scale it. But for right now, we need to understand how to use it. Does that make sense? Hello, Future Nurse Academy. Okay. I mean, I could show you a bigger number if you want to, if you really care. right? Like, this is too easy. This, you make it too complicated. Okay, fine. Let's take this. We do 1, 3, 5, 7, 8, right? Are you trying to make both sides equal? I am trying to make both sides balanced. So this 5 plus 2 gets substituted into 3. So when I have here the question 4 plus 3, right? My question is this 4 plus 3. When I add the 4 and I need to add the 3, I need to substitute plus the 5 minus the 2, plus the 5 minus the 2. My answer is 7. Here's another way. I have 4 pennies. I have 4 pennies. They're on my abacus. They're right here, right? I have 4 pennies. I only have a nickel. I only have 5 cents to give to you. I'm going to give you 5 cents. We're looking at 3. If I give you 5 cents, but it's only worth 3, then I give you too much. So if I give you 5 cents, I'm going to add the 5 cents. I need to take away 2 cents. So your final answer is 7. Does that make sense? So what we're doing is we're substituting our numbers. That's what we're doing. So we're going into more algebraic, right? So this is the stepping stones of algebra where we start substituting information. We isolate the variable and then we substitute our information. This is the steps of doing algebra. Abacus is the gateway to complex math. And so when we start talking about how to add, we start going into critical thinking. So that makes sense. With the money, did that make sense? Did that help? So here's a bigger question, right? This question is really big. Yes, this question is big, but because we know the fundamentals, it is now scalable. If we look, 1, 3, 5, 7, 8. What are we going to do? We're going to add 2. Is there enough to add 2? Right? We can add 2. Can we add 4? We're going to add 4 here. You're a great teacher. I hate math, but you make it fun to watch. Oh, good. Thank you, Katie. Teacher at my school, I always use a calculator to make numbers to make answers. Yeah, you could. But your brain is that calculator actually. So my question is back to here. Can I add the 4? How do I add the 4? Do you remember how to add the 4? How do we add the 4? Plus the 5 minus the 1. Plus the 5 minus the 1. And then what do? We plus the 3. Can we add the 3? Yes, we can. We're going to add the 3. Can we add 1? Yes, we can. We'll add the 1. Can we add another 1? Yes, we can. We'll add another 1. So my final answer is what? 37,889. The blue ones are 5? Yes. Yes, it is. Oh, sale. You're right. You're absolutely right. The blue is 5. So when we look, this is 3, 1, 2, 3. This is 7, 5, 6, 7. This is 8, 5, 6, 7, 8. 5, 6, 7, 8. And then this is 9. 5, 6, 7, 8, 9. You're absolutely right. Thank you. Yes, very observant. Well done. Does that make sense? Oh, excuse me. Oh, can a big number where we carry the 1? Yes, we can. Are we ready? Because what we're going to do is we're going to understand how to make a 10. That makes more sense, right? So we're teaching the kids how to make a 10. Okay, good, Osale. So we're teaching the kids how to make a 10. It's the same concept. If you look, so let's do a question. So we have a question. What are we doing? We are going to look at my other book. Here we go. Oh, excuse me. 9. My question is 9. Notice when I have the 9 on my abacus, I don't have any beads. I need to add the 8. When I add the 8, oh man, 10 is my enemy. No, 10 is not your enemy. 10 will be fantastic. So when do we get to square root? After division? But right now we're only adding, subtracting right now. So here we do 8. 8? Is there enough? No, there's not enough. What do? We know that the 8 and 2 makes a 10. Notice it's a very similar concept. Because 8 plus 2 is equal to 10, let's isolate the 8. When we isolate the 8, because this 8 and this 8 are the same, what are we going to do? We're going to replace this, substitute this. So what do? Plus the 10 minus the 2. What is your answer? Did that make sense? 9? No, Benny Jets. It is 1, 7, 8, 9, 17. Don't forget the 1. Thank you, King. Did that make sense? So we just carried the 1 over here. The 10, right? Remember when I was counting, we had 9. This is 9. 5, 6, 7, 8, 9. This is 9. What does 10 look like? 10 looks like this. 1 and 0. 1, 0. So when we add 10, we're adding the 1 on this side. And then here it says take away 2. When we take away the 2, right? When we take away the 2, remember we take away the 2, we move it away from the horizontal bar. Now we have 17. 1, and then 7. 1, 7, 5, 6, 7. So now we have 17. We can do it again. We can do it again. And I'll show you how versatile understanding this concept is, right? So we have 4. Can we add the 8? No, we can't add the 8. What do? What do? We plus the 10, take away the 2. We're given instructions. We're given instructions how to do it. Plus the 10, take away the 2. Each column, no, I understand. Each column is a place value. We have our ones, our tens, our hundreds, our thousands, our 10,000. Our decimal sits between the ones and the tenths, right? So what's going to happen is these are my tenths and my hundreds. These are my decimals. When we look, notice that there is a dot. There's a speck right there. That's my ones indicator. It's not my decimal. It's my ones indicator. It's like my comma, because this would be my thousands. Every comma, every grouping is groups. It's grouped into group separators. I could choose this one if I wanted to. If I wanted to choose that one, it'd be like this: ones, tens, and then there would be no more hundreds. So that's why I choose this one. Which one is the highest number? We can do 9. 9 is the highest number. This would be 999,999.99. It would look like this: 99,999.99. That is the highest number on this abacus. If you wanted a bigger abacus, because size matters, where are we? Here. This one is a 13 column abacus. This 13 column abacus is the same concept. This is the one. If I choose this to be the ones, right? There's a dot there. This could be my ones. Ones, thousands, millions. Or I could choose this one to be my ones. Ones, thousands. Ones, thousands, millions, billions, trillions. Right? If you wanted to track the national debt, you would have to get a bigger abacus. This is a 23 column abacus. This one's made out of bamboo, but they work exactly the same. It just happens to be bigger and longer because size matters. But these are made out of plastic and they work exactly the same. They're just as not delicate. They're just as easy to move, and they're as in the shapes are the same. Just use the top. We want to be gentle, We want to be gentle with our beads. We don't want to be aggressive. We don't want to be aggressive. What we want to do is we want to be able to just kind of move the beads. But remember, don't flick too hard. Don't flick too hard, because once if you flick too hard, then your answers will be wrong, because what happens is then all your beads will go all over the place. So do not flick too hard. All right. How are we doing? We're all right. So that's about how to make a 10. Are we, do you want to continue on how to make a 10? Or are we good with that? Because don't forget, if you notice, if we know how to make a 10, we know how to minus a 10, right? We know how to minus an 8, right? We know how to minus the 8. Why are we going to do that? Why are we going to? Because if it's like, I don't know, 16 minus 8, right? It's the same thing. Same thing. What's going to happen? We go 16 minus 8. Minus 8 is what? Minus 8 is equal to minus the 10 plus the 2. Very similar. They're only opposite operators. So we're going to minus the 10 plus the 2. My final answer is 8. One question, what happens if you get the wrong answers? I'm guessing you need summer school? No, 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 no. If you get the wrong answers, then you do it again until you understand why it's wrong. The biggest thing is understanding why you get it wrong. It doesn't, if you get it wrong, that's fine. But you have to understand why you get it wrong. You know what I mean? So you should always go back and check your answers. You should always go back and check to see why did you get it wrong? Why? Why? It's always that way, no matter what it is, whether it's spelling, whether it's science, whether it's whatever you get wrong, the best way to learn is to go back to see what you failed on. You know what I mean? The most important question in math is why. Yeah, and you know what? That is why I teach it the way I teach it, because I want to know, why am I using a plus 10? Oh, no wonder. Why am I using a 10? Because I don't have enough beads. That's why. Why? Why? I don't, who says that? Why? Why? There was a comedian that says that, and it just rings in my head. Okay, sorry. So, RT, does that make sense? If you have the wrong answers, you don't go to summer school. You just go to your question and you just do it again until you understand why you got it wrong. That's all. It's not a huge thing to get stuff wrong. I mean, we get stuff wrong all the time, right? It's understanding and learning from it. Okay. So does that make sense? What we did is hey, Neon, welcome back. Yeah. Yeah. So, I mean, the one of the that was the one thing that I changed the way I taught was I got my kids to go back. If they got the answers wrong, I got my kids to go back and say, "Hey, why did you get it wrong? How can we make it better?" Okay. So Katie, how are we doing, Katie? Are we okay? Benny Jets, how are we doing? It's almost 12 for you. It is almost 12. It is almost 12. It's almost 3. Oh my God, it's almost 3 for you. Good. Okay. Okay. So does the adding of the 8 make sense, and minusing the 8? Does that make sense? So what we just did is we compounded our information, right? We compounded, and we're practicing, and we're just making that concept more solid. But it's the same concept, which is really fascinating. It's not a different thing, right? It's the same concept, but different, like different elements, if you would say. So that's the secret. If you wanted to know the secret, that's the secret. The secret to all adding and subtracting is understanding how to use a 10 and how to use a 5. If I can find my little, there we go. So that's the secret. If you know how to do this, then everything is scalable no matter what. You can do everything adding and subtracting under the sun. You don't need to worry about any other strategies. That's the secret. Brian. That's funny, right? Okay, so here, let's continue on. There's this thing called two-step equation. Why are we doing two-step equation? Because we know the fundamentals of adding a 5 and writing down the secret. We know the fundamentals of adding a 5 and adding a 10. Now, what we're going to do is we're going to Tetris. Anybody know how to play Tetris? Tetris. Anybody know how to play Tetris? That's what we're going to do. We're going to do a little bit of Tetris in math, in the abacus way. Tetris my way through. Oh, maybe I'll do that as a phase. Tetris. That's brilliant. Yes. Yes. Good, good, good. Good, good, good. What are we doing? I gotta find my oh, here it is. Here it is. Here it is. Play Tetris to learn secret. Yes. Yes. The first thing we're gonna do is understand this. 8 plus 5. We could do it. 8 plus 5. 8 plus 5. That's easy. We could do it. 8. Do I have enough beads to add the 5? We do not have enough beads to add 5. I need help on 2 plus 3. Wait, I'm sorry. Teacher, do you learn art? No, I don't. I'm trying to draw, but that's as far as I go. I need help on 2 plus 3. 2 plus 3? The question is 2 plus 3? You're loved. Thank you. 2 plus 3. We're going to do this. 2. What do we do? What do we do? 2 is equal to 5. That's too much. Minus 3. Why are we doing that? Why are we doing that? Because if we do 4, and I want to add the 2, cannot add the 2, what do I do? Plus the 5, minus the 3. Answer is 6. Abacus is art. Oh, you guys are so funny. Penny jets. Does that make sense? So what did we do? We did 4 plus 2. That's what it is. So we have 4 plus 2 is plus the 5 minus the 3. Plus the 5 minus the 3. My final answer is 6. Yeah? You sure? Easy. Easy peasy. Easy peasy. So what are we going back? We're going to go back to do this. We're going back to do this. 8 plus 5. 8 plus 5. We can do it. Can we do it? No, we can't. That was a tough one. No, it wasn't. That wasn't tough. It's all in your mind. Open your eyes. I feel like Total Recall when he says that. Open your eyes. Open your eyes and see. Okay, so what are we doing? We're doing a 5. When we add the 5, what are we going to do? We know this concept. 5 plus 5 is equal to 10. 5 plus 5 is equal to 10. What happens? So if we did 5 is equal to 10 minus 5. Does that make sense? So what are we going to do? We know we're going to add the 10 and then we're going to take away the 5. That's what we're going to do. So we're going to add the 10. We add the 10 and look, oh look, we can take away the 5. So my final answer is 13, which I wrote here, 13. Make sense? Now let's do it again. This is the same. No, 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 it's not the same. 5. We'll do 5. Let's do 5, right? We add 8. We know how to add 8. We've done that before. We can add the 8 over here, right? What is adding the 8, right? We know adding the 8 is plus the 10 minus the 2. Plus the 10, take away the 2. What? Thank you, Neon Panther. Plus the 10, take away the 2. I can't take away the 2. There's no 2 to take away. There's no 2 to take away. Thank you so much for the rose. We cannot take away the 2. What do we do? We know. Who is it? Benny Jets. You should know this one a little bit, right? If we cannot take away the 2, what do? We know to take away the 2, we need to minus the 2 equals minus the 5 plus the 3. It's just the opposite. So minus the 5 plus the 3. Our final answer is 13. That's what it is. That's it. Maybe. Maybe. Oh, I did it here again. So again, it's all about the add-in. It's all about the add-in. But see, you were asking about the 2 and the 3. The 2 and the 3, these are pairs. These are friends. These are peoples. What kind of wizardry is this? I need to learn more from you just to be more focused. Oh, thank you so much. But see, when we know the fundamentals, we understand the fundamentals, we know the very basics, then what happens is we can scale it. That's where we come into the bigger numbers, right? When we come into the bigger numbers, this is actually not scary anymore because we can use the abacus to help us. Make sense? So going back, right, we just need to understand the fundamentals. Once we understand the fundamentals, we just go back. This everything you see here, everything you see here. Oh, here, right? Everything we see here. All of this stuff, how to make a 5, adding 5, take away the 5, adding the 10, take away the 10. That's all the same thing. The soundboard is amazing. Yeah, thank you, Neon. I'm scared to the big numbers. Could you find the exact values of 23 pi divided by 12? Messer lover. I don't even know what that means. I don't know how to do that. I don't even know what that is. Is that algebra? I don't know if I have enough columns to show you. Ah. Okay, so scared of, no, but see, look at the big number. Let me show you the big number. This is the big number we're talking about, right? I'll show you how easy it is. Right? When we look 1, 3, 5, 7, 8. Right? Do we know this? We know this, right? Easy. 1, 3, 5, 7, 8. The next number, we have 2. Can we add 2? Right? We add the 2. Here, I need to add the 4. There's a 4 here. Can I add the 4? How do I add the 4? I thought you were taking random math questions. No, sorry, Messer Lover. Big numbers find me in my nightmares. No, pun. No, no. Look, look, look. How do we add the 4? We know how to add the 4. How do we add the 4? I'm just do arithmetic. I don't take any random numbers. I'm showing you how to use the abacus. That's what I do. I'm teaching everybody how to use the abacus and not be scared of math. That's what I do. Don't be scared of math. So how do we add the 4? We know how to add the 4. Right here. Plus the 5 minus the 1. Add the 5, take away the 1. Then my next one is what? Add the 3. Can we add the 3? Can we add the 3? Add the 3. Yes, we can. Right? Ooh, I almost flicked too hard. Then what do? We add 1, we add another 1. That's it. That's the answer. What's the answer? 889. Yes, thank you, Benny Jets. Exactly. Right? Easy. Because why? Because we could see it on the abacus. It's always the biggest question. Can we do it? Yes, we can. I can't read the beads. Oh, yeah, right? So, pun, here's the question. 1, 2, 3, 4. Right? Does that make sense? This is 4. Anytime the beads are touching the horizontal bar, this is counted as 4. So it'd be like these pennies, right? I have 1, 2, 3, 4. Pun, are you still there? Anytime the beads are touching this horizontal bar and they're in contact, this is being counted. So this is counted. These are 4. These are not counted. These are all zeros. 5 is this. This is 5. The 5 will always be the top bead. No matter what, 5 is always going to be the top bead. The top bead always equals to 5. And then we have 6, 7, 8, 9. And that's it. That's how we read the abacus. Nothing more. That's it. There's nothing more. 10. Look, it's 1. 1 and a 0. 90. 9 and a 0. It's very similar to the way we write. 100. 100. Right? We have our ones, our tens, our thousands. Yeah, go to the bathroom, RT. I that's fine with me. Does this work with pesos or euros currency? Oh, I understand that. Thanks. Yeah, not a problem, Benny Jets. Brian, I'm assuming it would work with pesos and euros. Yes. I don't know if they have 1 cent. This is how my Korean mom made me learn math. Oh, that's fantastic. This is true magic. Yes, thank you. uh, oh, yeah, this is what it was. It was, oh, oh, I think need to make that shorter. But yes, it's very elegant the way abacus is done, right? The way the abacus is built, it's very elegant. And it's just quite amazing. So, Clint, do you made me do math? How far have you gone through your math on abacus? Did you go all the way to multiplication and division? Yeah, Clint. Oh, I don't know if Clint is still here. So does that make sense? What we just did, right? The big numbers are not scary. It just depends on what we're trying to do. But you have to be careful with the numbers themselves. That's why we have to look at our add-ins. You can't just look at this, right? You can't just say, "Oh, this is the number," right? That in mainstream math, they give you just 2 digits like this, and they're like, "You know what? Just memorize that 8 plus 5 is 13." No, 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 no. Why is it, right? How do we make it? And it goes back to understanding the add-ins. Oh, I don't know if Clint's still here. I'd like to know if he knows multiplication and division. Okay, so welcome back, RT. So does that make sense? So what we're doing is, so what we can do is we could do two-step equations. Why? What are two-step equations? Two-step equation is the Tetris, right? What I was talking about, Tetrising. We did a little bit about it, right? We did this one, and then we did 7. Did we not do 7? No, we didn't do 7. So here's 7. So let's Tetris our way through. Now, why is it critical? Because that's everything under the sun. If you know how to, if you're solid in understanding your adding of the 5 and adding of the 10, then you can do anything. It just depends on the order and stuff. So the question was 7 plus 7. Again, what we're doing is we're taking the basics. I want to add 7 to my abacus. 7 to the abacus. I want to add another 7. When I add another 7, it's what? 7 is equal to what? 7 is equal to what? 7 plus 3 is equal to 10. That's what we're looking for. This is what we're looking for, Benny Jet. Okay? So what happened is what? We're going to isolate the variable. 7 equals 10 minus 3. Why? Why? Because I need to add the 7. When I need to add the 7, I don't have any more beads to add the 7. What is the partner of 7? The partner of 7 is 3. So I'm going to rewrite it, right? Plus the 10 minus 3. Plus the 10, take away 3. Oh, nuts. Minus 3. I don't have enough beads. I don't have enough beads to minus the 3. What do? This is where we get two-step equation from. Why? Because we got to break this one down. We got to break it down into manageable chunks. So how do we minus the 3? We know how to minus the 3. Thank you, Neon. Yes, minus the 3. Looks very familiar, doesn't it? Minus the 3. Minus the 3 minus the 2 equals minus the 1. What are we doing? We're isolate the variable. Minus the 3. Minus 3 equals minus 5 plus 2, just as Neon said, right? Minus the 5, right? Minus the 5 plus the 2. My final answer is 14. 14. That's a two-step equation. Okay, see you later, Benny. Thank you for joining. I'll see you next week. I will not be here tomorrow. Bye. Oh, actually, that makes sense. Oh, good pun. Good. What about, ooh, that's a good one, princess. So we look, if we did, right? What is this equal to? This is equal to 9, right? So if I had my question, let's do this one. 2, I want to plus the 9. Plus the 9. Oh, sorry, plus the 9. I want to plus the 9. Plus the 9 is what? Plus the 10 minus the 1. I'm going to plus the 10, take away the 1. My answer is 11, right? We can do it again, right? Yeah, no, that's a very good question. That's a because now you're understanding. You're really understanding. So here what it is, right? What you told me was what happens if we did this? What happens if we did 10 minus 1? Well, if we wrote it, it would look like this. That's what it would look like. So when we do it, right? Here's another question. Let's do 4. Let's do 4. I do 4. 1, 2, 3, 4, right? 4. If I want to add the 9, it's plus the 10 minus the 1. So what do? I plus the 10, right? Because I'm adding the 9. And I take away the 1. My final answer is 13. Yeah? Yeah, that's a very good question. That's a very good question. So Neon says minus the 10 plus the 9. Minus the 10. I feel like a genius. Good. Good. Yeah. That's the greatest thing, right? Because now you know what's going on. Now you know. What is it? Where is it? That's crazy, right? So it's kind of about memorizing the buddy. Yes, thank you, Katie. The buddy numbers. Yes, memorize the buddy numbers, and you're set. You don't. You can do everything else under the sun. It has now become scalable. Oh, so the other one, right? Neon said minus the 10 plus the 1. Why are we doing this? Because it would be a minus the 9. So if it's minus the 9, let's do 18. Let's do 28. 28, right? 28, take away, let's do 28 minus 9. We have 20, we have 8. Minus the 9. Minus the 9 is minus the 10 plus the 1. Minus the 10 plus the 1. My answer is 19. But yes, Katie, it is exactly what it is. You memorize the buddy numbers. You know how to do a 5, you know how to do a 10. That's it. How are we doing? We're all right? Make sense? Are we making wrinkles in your brains? Right? Good. Fantastic. How do you have a sheet with all of the buddies? How do you have? Yes, I do. This is it. Oh, let me show you. Um, it's actually quite nice. I do like this product. Um, this one. So this is my abacus formula. This is utilizing all of the 5s and the 10s, right? And so when I look at it, I have my adding of this is making the 5. And so I have a definition here. It says commutative property, which means that you can flip it. You can go plus the 5 or minus the 5. Plus or sorry, plus the 5 minus the 1 or minus the 1 plus the 5. You could do that, and then there's a subtraction. And then there's pairs. And then there is the other side, which is the tens. The tens is the same way, right? And it follows the same path. Notice that? And then I have it where you can utilize and you can write it. And this is all laminated. So this is all laminated, and you'll see that you'll have instructions to isolate the variable, make the 4 by itself, subtract on both sides, and then write the formula in the commutative property. And then after that, I show you how to do it on the abacus. So every one of them, it will tell you if I need to 4 plus the 4. If I have 4 here, and I have another 4, I'm going to substitute it, right? Minus, plus the 5 minus the 1, and I do it together like that. Sorry, and doing great. And you can read it with a Sharpie. Yes. Are there benefits of using these? Does it make things easier once you learn it? I believe it makes it easier when you learn it. That's why I'm teaching it. I don't see why we have other strategies, but I don't teach the other strategies. I just teach abacus. And so I believe it's the greatest thing next to sliced bread. Oh, and so that was the other thing, Katie. So what I did here, this is the prototype, but there's a label here that you'll see where it says the plus 5, and then we're adding the 4, and then I do it for the 3 and the 2 and the 1, so it's easy reference. And then I have a separator that says making of the 10, and then after that it's the same thing. So we have the 10, right? And again, this is the plus 10 plus 9 plus 8, and then these are all the indicators, right? And then after that, you see all of this, and then after that, here's the framework. This is the secret sauce. I meant to say it with a Sharpie. Yeah, yeah. Well, no, I use a dry erase. Don't use a Sharpie because you don't want it to be permanent. You want it to be, I don't want it to be permanent. So I always erase. So I do it with a dry erase. So here is the question, right? Here is a sample question. Here is 7. When I have 7 and I add the 4, is there enough to add the 4? Yes or no? No. So what do? I have to check to see, can I use the 5 bead? Can I use the 5 bead? No. So what do? I go to my 10. Can I add the 10? Yes. What do? Plus 4 is equal to plus the 10 minus the 6. Plus the 10 minus the 6. And my answer is 11. Does that make sense? So what did I do here? What I did was I added a framework of this is what we talk about for every number, take it one step at a time. So here it is, 17. I have 17. Can I take away 4? No, I can't. What do? I can I use the minus the 5? Can I take away the 5? Yes, I can. So what do? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1, and my answer is 13. Yep, that's what this is. So I called it abacus formula, utilizing the 5 and the 10 on the abacus. So, Bug, did I answer your question? I don't know if I answered your question. Yeah. So I really like this. It was very inclusive. Um, yeah, and this is not a Sharpie. I would do a dry erase. hmm So you can always go back to practice. hmm And then if you're a teacher, right, or if you have kids and you want to teach your kids. Okay, so how are we doing? What's going on? Now I'm just cleaning. Thank you for liking the lives, people. Thank you so much. I appreciate that. All right, how are we doing? Doing great. Okay, great. So that's about the 2 steps. So after we learn how to do 2 steps, we can do more 2-step, or we can go into multiplication. What do you guys want to do? That would be the next step, is to understand multiplication. Yeah? Okay. Excuse me. And I think I'm going to sign off after the multiplication because I just got tired. Ugh, ugh. Okay. Man, these college requirements getting crazier every year. Yeah, I heard you're not allowed to bring the calculator. You can bring an abacus. Just so you know, you can bring an abacus to the college, whatever it is. But that's what I heard. Looks like teacher needs coffee. Ah, okay, excuse me. What are you doing? We are cleaning. We're gonna get rid of this. Okay, what are we doing? We gotta do this. Okay. Heck, yeah, it's gonna be doing double integrals on the big thing. Okay. I don't know I don't know what double integral means. If you can explain it to me in simple terms, I can try to help you. But I honestly don't know what integral means. I'm not smart. I only know the abacus. It's calculus thing. Just a joke. I love what you do here. Oh, we can do. Oh, yeah. Okay. So what are we gonna do? We're gonna do multiplication. Now, in multiplication, what we do is in abacus world, we don't need to know anything higher. It feels like learning. I'm sorry. Feels like we're learning like a Pokemon. Yeah. The one thing that we want to do in abacus world is we don't need to memorize anything higher than 12. I don't know why we teach the kids to do that. Okay, here is a question. This is a fun question. Let's see how this works. 83 times that by 5. The first thing we're going to do is understand what? We're going to understand to count our digits. Because why? We need to understand where are we going to put our answer. The abacus helps us place our numbers, reads our questions, finds our question, right? So what is it? What are we doing? One, two, three. So we're going to be in the hundreds column. One, two, three. This is where we're going to. I think for kids are easier with calculator for kindergarten. No, they're not allowed to use a calculator for kindergarten. Excuse me. Yeah. Yeah, they're not supposed to use a calculator because they need to understand the numbers. They need to understand why. They just need to understand how to add. If they use a calculator, it's like a big hole, right? They need to know how to add. One, two, three. So the first thing we're going to do is we're going to do 5 times 8 is 40. 1, 2, 3, 40. 4 and a 0. There's a 0 here. So the next thing we're going to do is 5 times 3 is 15. Add 1, add 5. And that's my answer. That's it. I'm done. 415. All right. I do apologize for yawning. But yes, I am gonna head out. That's a very big yawn. I am done. When I yawn that much, I am done. I have to go to bed. Thank you. No, thank you for joining, Pun. I hope that makes sense. I hope if you ever have kids or you know people that they will learn how to use the abacus, and I hope you teach them. That's the whole point, right? The whole point is getting everybody to teach everybody else how to do abacus. So thank you guys. Thank you. I think I mastered the abacus. Good pun. Good. Have a good night, Katie. Thank you so much for joining. See you later, Neon. I will see you. I think your teacher to learn. I'm sorry. Teacher to learn me to teach me like that. Same. Bonjour. Hey. Comment ça va? Oh, ça va fatigué. Je suis fatigué. I am going to sign off Bible. Shoemaker. Shoemaker. I have to talk to you, Shoemaker. Yes. Thank you so much. Thank you so much for joining, but I am going to sign off. Yes. Is there any other questions before I sign off? Uh, Shoemaker, just so you know, I'm not going to be here for the week. Just so do you know, because I'm going to go to science camp. There's a camp. I am chaperoning my child over at science camp, and I will be gone for about a week. So I will not be on, just so you know. But I should be back either Friday or Saturday of next week. Yeah, yeah. Have a good night. Enjoy yourself. I don't know how much I can enjoy myself if I'm chaperoning 100 kids. So, but yeah, just so you know, that's what I'll be doing. Um, for a week. So I won't. I probably will. I won't be back. Maybe Friday or Saturday. It just depends. But for sure Saturday. I don't know if I'll come back. I don't know if I'll do it on Friday night. Okay. Au revoir. Bonne tête. Bonne suite. I don't know. I don't know. I forgot my French. You can't beat them. Join them. Be a kid as well. Yeah, you're absolutely right. You're absolutely right, Shoemaker. All right. Okay. If anybody else has any questions, I am going to sign off. Thank you again for joining and have a good night and a good week. Everybody have a fantastic week, and I'll see you all next week. Bye, everybody. I have 49 people. Fuck. I'm tired.